Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P0722, indicates a significant problem in the output shaft or countershaft speed sensor circuit, specifically noting the lack of signal input. In the Honda Odyssey models from 2011 to 2017, this DTC often stems from electrical circuit issues rather than mechanical problems within the transmission itself. The output shaft speed sensor is crucial for accurately monitoring the rotational speed of the output shaft, which directly influences transmission performance and vehicle dynamics. When this sensor malfunctions, or the signal cannot be transmitted due to wiring issues, it can lead to erratic transmission behavior, affecting vehicle acceleration and shifting. The key components involved include the output shaft speed sensor, the powertrain control module, PCM, and associated electrical connectors. It is vital to perform a thorough diagnostic before making any assumptions about potential mechanical failures in the transmission. The output shaft speed sensor plays a vital role in monitoring the rotational speed of the output shaft, also referred to as the countershaft in the transmission. It is typically located within the transmission assembly, attached to the housing, where it can directly measure the rotations of the output shaft. This sensor is connected to the powertrain control module, PCM, which uses the sensor data to manage and adjust various aspects of the vehicle's transmission and drivetrain functions. A reliable signal from this sensor is absolutely essential because the PCM uses this data to ensure proper shifting and overall performance of the vehicle. If the output shaft speed sensor fails or the circuit experiences issues, the vehicle may face significant performance problems, including harsh shifts or erratic behavior during operation. The primary possible causes of DTC P0722 largely revolve around the vehicle's electrical system. One common issue could be faulty or damaged wiring in the circuit. Over time, wires can deteriorate due to exposure to heat, moisture, or abrasion, leading to open circuits that prevent the sensor from generating a signal. Another potential culprit is a defective output shaft speed sensor itself, which may not operate correctly due to internal failures. Lastly, a poor connection between the sensor and the powertrain control module, PCM, can also result in lost signals. It's crucial to carefully inspect all wiring and connections to identify any issues that may lead to this DTC setting. Symptoms associated with DTC P0722 can vary, but generally include erratic shifting behavior in the transmission. Drivers may notice that the vehicle shifts abruptly or unexpectedly as the transmission struggles to receive accurate data about the output shaft speed. Another prevalent symptom is the illumination of the check engine light on the dashboard, indicating that the onboard diagnostic system has detected a problem. Additionally, the overall performance of the transmission may suffer, leading to delayed engagement in the gears or difficulty accelerating smoothly. Understanding these symptoms can help in diagnosing the underlying issues promptly before they impact the safe operation of the vehicle. The initial step in troubleshooting DTC P0722 involves turning the ignition switch to the on position, referred to as the to position. This enables the vehicle's systems and prepares it for diagnostic work. Importantly, at this stage, it is crucial to record all freeze data, which includes the conditions the vehicle was operating under when the fault occurred. This data can provide valuable insights that may guide the technician in pinpointing the exact issue. Additionally, reviewing general troubleshooting information is essential, as it offers context and guidelines for effectively addressing DTCs like P0722. These preliminary actions set the stage for a thorough diagnostics process in identifying and resolving the malfunction. After recording relevant data, the next step is to clear the DTC using the Honda Diagnostic System, HDS. The HDS is a specialized scanning tool designed to interface with vehicle systems, allowing technicians to diagnose and clear fault codes effectively. By clearing the code, you create a clean slate for testing the system again and ensure that any persistent errors are genuine. It is not uncommon for intermittent codes to occur, and clearing the DTC can help determine whether the issue leads to a consistent fault or if it's a temporary glitch. Once cleared, monitoring the vehicle's performance again will provide insights into whether the original issue has been resolved or needs further investigation. The third step involves preparing the vehicle for a safety check and diagnostic run by blocking the rear wheels and lifting the front of the vehicle. This ensures that the vehicle remains securely supported during testing. It is critical to use proper jack stands or ramps to lift the vehicle safely. The goal here is to allow the front wheels to rotate freely, simulating real-world driving conditions while the engineer observes the output and input shaft speeds through the diagnostic system. Evaluating the vehicle in this safe state enables accurate readings, as any movement of the wheels can result in discrepancies in the data collected regarding the RPM, revolutions per minute, of both shafts. In this step, the technician will start the engine and immediately disable the Vehicle Stability Assist (VSA) system by pressing the VSA off button. This action is essential as it allows for a clearer analysis of transmission performance without the limitations imposed by the VSA monitoring system. The vehicle is then placed in drive, and the technician will run the engine at speeds above 2,000 RPM, which is necessary for accurately comparing the input shaft speed against the output shaft speed. Using the HDS, the technician can monitor these values in real time. After this, a careful observation will confirm if the speeds are approximately the same, an essential step that dictates the next phases of troubleshooting. If the speeds of the input and output shafts do not align, proceeding to Step 5 is necessary. The technician must turn the ignition switch to the lock position, which ensures the vehicle is completely powered down before any electrical components are accessed. This prevents accidental shorts or further electrical issues. The next action involves disconnecting the output shaft speed sensor connector, which will allow for testing the circuit integrity and verifying the condition of the sensor itself. Disconnecting the sensor is a critical step in troubleshooting, as it will help isolate the issue to either the sensor's performance or the related wiring and connectors. With the output shaft speed sensor now disconnected, the next step is to turn the ignition switch back to the on position. This allows the vehicle's electrical systems to power up, enabling precise voltage measurements to be taken. The technician will measure the voltage at the output shaft speed sensor connector, specifically between terminal number 3 and the vehicle's body ground. This voltage is expected to be around 5 volts, a critical threshold indicating that the sensor is receiving appropriate power. If the voltage measured is satisfactory, it signifies that the circuit upstream is functioning correctly, allowing the technician to advance to the next troubleshooting phase. However, if the voltage is absent or incorrect, it signals a potential wiring issue between the powertrain control module and the sensor that needs immediate attention. After confirming the voltage at terminal number 3, the next logical step involves measuring the voltage at a secondary point, particularly terminal number 2 of the output shaft speed sensor connector. This measurement provides additional confirmation regarding the sensor's operational integrity. If the voltage at terminal number 2 yields a satisfactory reading, it strongly indicates that the output shaft speed sensor is functional. and that the fault may lie elsewhere in the circuit. Conversely, if the voltage is markedly absent or significantly lower than expected values, it suggests that the sensor may be faulty. This testing phase is vital for determining whether to repair or replace the sensor as a solution to the DTC. Upon completing all necessary repairs, it's essential to run a final verification to ensure that the issues have been resolved. This involves performing a series of tests to confirm that the output shaft speed sensor now operates correctly and that the DTC no longer appears in the system. The technician should also verify that all electrical connections have been restored securely. Following these checks, a final test drive can be performed, monitoring for any signs of erratic behavior or performance issues. This step is critical, as reintroducing the vehicle into full operation ensures that all systems are back to normal and that the resolution has been effective. Preventive maintenance plays a crucial role in avoiding future occurrences of DTC P0722. Regular inspections of the wiring linked to the output shaft speed sensor can identify wear and tear early, allowing for timely repairs or replacements before they lead to significant issues. Additionally, monitoring the overall performance of the output shaft speed sensor will help in detecting problems early in their life cycle, ensuring that any electrical connectors are clean and free from corrosion will maintain reliable electrical connections, which is vital for all sensor operations. Adopting these preventive strategies can significantly extend the life of the transmission system and enhance the overall driving experience. In summary, addressing DTC P0722 requires a comprehensive approach to diagnostics and repairs, focusing primarily on the electrical components related to the output shaft speed sensor. Identifying and resolving wiring issues and confirming the integrity of the sensor is crucial in rectifying the fault code. The insights gained from thorough testing and verification offer valuable pathways for preventing reoccurrence of similar issues in the future. Moreover, implementing regular maintenance practices will not only assist in early detection of potential problems, but will also ensure optimal performance of the transmission system over time. Staying proactive is key to maintaining the reliability and safety of the Honda Odyssey. Please like and subscribe to the channel. See you next time.